Okay, I chose a really, really challenging problem for us to practice our learning target here today. It is the same as yesterday. We will solve real world problems involving fractions and mixed numbers. Okay, first I'm going to start by reading our problem. Like I said yesterday, I think one of the most challenging skills in all of math is really applying the things that you know, the little skill pieces you know, to real world problems. So this is where it gets tricky when you get into some multi step problems. A bin at Walmart has a total of 45 bouncy balls. 2/5 of the bouncy balls are orange, 6/15 of the bouncy balls are purple. The remainder of the bouncy balls are yellow. How many bouncy balls are there? Okay, now there's a couple ways we could do this. I am just going to kind of ignore our modeling for right now. And then when we get towards the end, we'll go back to that and use our bar modeling to help us here. But let's start with what we know. We know that there is 45 bouncy balls, and 2/5 of the bouncy balls are orange. 6/15, I'm going to use a different color for this. I don't have a purple marker, otherwise I'd use it. 6/15 are purple, and the remainder are yellow. So we have some purple bouncy balls, some orange, and some yellow. Okay. Now, what we want to figure out is how many of them are yellow. I would say a really great place to start on this problem would be to figure out how many are the two fraction pieces we already know. How many of the bouncy balls are either orange or purple? Because we know those fractions. Once we figure that out, we can use subtraction or fraction of a set to help us find how many are yellow. Okay. So I'm going to start by kind of taking some notes of the things we know here. We know orange is 2/5, and we know that 6/15 are purple. Okay. Now I think the easiest thing to do, I'm looking at my two denominators right now. If I want to add these up and find out how many balls are either orange or purple, what I can do is turn these fractions into a common denominator, and I see that 5 and 15 share a common multiple. So if I made my list of common multiples of 5 and 15, and those of you who have fact fluency, this is going to be easier and easier for you. I'm going to write my multiples of 5 first. 5, 10, 15. Oh, it's right there. So I can turn my fraction of orange balls into 15s. That will help me figure out what piece is missing easiest, I think. So I'm going to write my 15 as my new denominator. I'm going to use multiplication to turn my 2/5 into an equivalent, which means equal, fraction with a denominator 15. So what times 5 equals 15? You can look at your list of multiples over here. And it is 3. Do the same thing to your numerator. 2 times 3 is 6. So what that means, if we add these two numbers up, we'll be able to find our total of orange and purple balls. Not how many, but what fraction of them are orange or purple. Okay, so 6/15 plus 6/15 is 12/15. And that is orange and purple. Okay, now what we could do is find out what 12/15 of 45 is. But what I think might be a little bit easier is to figure out how many 15ths are going to be yellow. Okay. Now, if we have 45 balls and our total is 15/15, that's one whole, we can subtract our orange and purple balls, 12/15. From that, I see my denominator is the same, so I can subtract across my numerators. 15 minus 12 is 3. So that means that 3/15, I'm going to circle this because it's important, are yellow. Okay, now I'm going to end up erasing some of this stuff right here because we need some more room to work and show our work. But I'm also going to write this over here. 3/15 are yellow. And these two numbers together should add up to 15/15, and we just did the subtraction to show that. Now I circled 3/15 are yellow. That's not our answer though, because our question is asking how many bouncy balls are there that are yellow. It's not asking us what fraction are yellow. If so, we had already found our answer. But what we need to do now is use our fraction of a whole number that we worked on a couple weeks ago or 2 weeks ago. So we need to figure out what 3/15 of 45 is. Okay. Now I could draw a fraction bar to help me with that. But I think using the multiplication and division would be a little bit easier. If I wanted to draw myself a fraction bar of this problem, I could do 12/15 are yellow orange and purple, and 3/15 are yellow. But really what we're doing is and it would take me a little bit of time to draw out 15, so I'm going to try and do it quick. Okay, I know those are not perfect, and I'm actually not going to even go through and count them all, but I know that 3 of these 14 have to be yellow. Okay, and the other 12 together are orange and purple. And we could even count out our 6/15, or sorry, our 6/15 are purple, and our 6/15 are orange. We could do that. And I know I'm using a yellow marker for both these, so that doesn't really help me. But what I need to figure out is how much is each one of these blocks worth, these 1/15 of 45. And then I need to count 3 of them to figure out how many balls are yellow. So what I'm going to do is I'm going to first start by breaking 45 into 15 equal pieces. That should sound like division language to you. 45 divided by 15. Okay. Now, I do happen to know my multiples of 15, but if you didn't, you could use repeated addition, you could use skip counting, you could use guess and check. I know that 15 times 2 is 30, and then if I add 15 onto that, I get to 45. So I know that 15 goes into 45 3 times. Okay, so that means that 1/15 of 45 equals 3. But we don't need 1/15, we need 3 of them. So instead what we're going to do is multiply 3 times 3, and we get our answer of 9. 9 yellow bouncy balls. Okay, here's our answer. So again, we're trying to find out how many of the bouncy balls are yellow. 9 of them are yellow. We could check our work by multiplying our 3. 1/15 of 45 is 3, and 3 times 12 is 36. Are orange or purple, and 36 plus 9 equals 45. 9 yellow balls, 36 orange or purple balls. I know this is a really long, complicated problem, so if you think bar modeling is going to work the best for you, that is okay. Okay, this is our last problem we're going to practice our learning target with today. Reggie and Jay go for a walk every morning. Reggie walks 2 1/4 miles. Jay walks 1 3/8 miles less than Reggie. How far does Jay walk each morning? So this is actually set up to be kind of a trick question. This is the same kind of question that I would expect to see on the MCA, where if you are not reading this very, very carefully, you might right away try and just write down that Jay walks 1 3/8 miles. Okay, that is not what we're trying to find. We're trying to find how far does he walk. And if you didn't read that super carefully, you might say, it says right here, Jay walks 1 3/8 miles. Yeah, duh. But that's not what we're seeing here in our clues. Our clues says he walks that much less than Reggie. So to find the difference between them, that's going to give us how much Jay walks. We have to use Reggie's number of 2 1/4 miles. And from that, we're going to subtract 1 3/8. That will tell us how far Jay walks every morning. Okay, it's not that he walks 1 3/8 miles. He walks 1 3/8 miles less than Reggie. Okay, so I'm going to go ahead and start with my subtraction here, but I see that I have uncommon denominators, 4 and 8. Hopefully, if your fact fluency is there, you should say, hey, Miss Brocker, I know right away the least common multiple of 4 and 8 is 8. If it isn't, make your list of multiples over here. Multiples of 4 are 4, 8, 12, 16. Remember, once you see the one they have in common, stop. Multiples of 8 are 8, stop. There it is right there. So what we're going to do is turn our fractions into fractions that are equivalent or are equal with denominators of 8. Now, right here, you're saying, this is already 3/8. Good, then you don't have to change it. You can rewrite it if you want. If that makes you uncomfortable to have that subtraction kind of like going crossways, then if you want to rewrite it, that's fine. Okay. 4 times what equals 8? 4 times 2, do the same thing to your numerator. 1 times 2 is 2. Okay. Now, once we have these common denominators, we can subtract, but hopefully you're saying, wait a minute, there's an issue here. We can't take away 3/8 from 2/8. We don't have enough. So this is why we practiced that regrouping 2 days ago. So you're going to come over here to your whole number. You're going to take one away. You're going to borrow one whole, which is 8/8, and you're actually going to do addition first. And that's going to give you an improper fraction. So our denominator is 8. 2 plus 8 here, the numerators, is 10/8. Now we can subtract 10/8 minus 3/8. 10 minus 3 is 7. And our denominator stays at 8. Okay, now normally we'd come over here once we're done with the fraction pieces. I cannot simplify or reduce 7/8. It's in its simplest form. I'm going to look at my whole numbers, and 1 minus 1 is 0. So, J walks 7/8 miles, or 7/8 of a mile.